Hello friends, welcome to my channel Master the Monster. Are you the one who think math is a monster? Are you frustrated with your heavy mathematical calculations? Are you haunted by the homeworks given by your math teacher? Are you annoyed about your mathematics exam? Now you can stop worrying. With little interest and regular practice, you can master the monster. All that you need to do is just subscribe to my channel so that you can join with me to overcome your fear for maths. Class 10 Cbse Maths Chapter 1 Real Numbers Exercise 1.1 Problem number 4. Use Euclid's division lemma to show that the square of any positive integer is of the form 3m or 3m plus 1 for some integer m. What is given in the problem? You have a positive integer. So let me take x as a positive integer. Right? Okay. Then you have to show that the square of the positive integer, that is x square, is of the form 3m or 3m plus 1. So I have to show that x square can be written as 3m or x square can be written as 3m plus 1. So x square can take any one of these two forms. This is what I am going to prove, right? And I am going to prove this using Euclid's division lemma. Already we have seen Euclid's division lemma in our previous videos. So I have given the link in the description box. So you can make use of it. Okay, now let us get into the problem. So to apply Euclid's division lemma, I need one more integer. Already I have one integer x. That is a positive integer, it's given. So let me take y as the other integer. And what is the value of this y? I am going to prove it is of the form 3m and 3m plus 1. So let me take that y equal to 3 itself. Okay, so that when I apply Euclid's division lemma for x and y, I get two integers q and r such that x equal to yq plus r, where this r lies between 0 and y. Taken y as 3, so x equal 3q plus r, so that r can take the value 0, 1 and 2. Okay. So I have got x equal to 3q plus r, where r has the value 0, 1, 2. Now when I substitute r equals 0, you get x equal 3q. When I substitute r equal 1, you get x equal 3q plus 1. And when we take r equal 2, x equal 3q plus 2. So x can be of the form either 3q or 3q plus 1 or 3q plus 2. Now let's come to the problem. We need to show that the square of positive integer. So I am in need of x square. So here x is of the form 3q, 3q plus 1, 3q plus 2. Then what about x square? Okay. Now let us consider the first format, x equal 3q. So if x equal 3q, what about my x square? X square will be 3q square. That is, this is equal 9q square. So I can write this 9q square as 3 into 3q square. This 3q square is of course an integer, isn't it? And also it is going to be a positive integer. So let me take this 3q square as m, so that I get this is equal to 3 into m, where m is some integer. So I have said that x square can be expressed in the form 3m. Okay, now let me consider the next case, x equal 3q plus 1. So if x equal 3q plus 1, then what about x square equal to? It is 3q plus 1 the whole square. So when I expand this term, I get it to be a plus b the whole square format. So it's 9q square plus 6q plus 1. Now let me group the first two terms. I can take a 3 common outside, so that I get 3 into 3q square plus 2q plus 1. Alright. Now you think of this 3q square plus 2q. This is going to be some number. It's some integer. So I can take it as 3 into, I can denote that number by m so that I get 3m plus 1. So x square can also be written as 3m plus 1. Okay, now let's consider x equal 3q plus 2. So when I take x equal 3q plus 2, x square will be of the form 3q plus 2 the whole square. Again, let's expand it using a plus b the whole square formula. So I get 9q square plus 12q plus 4. And now let me write this as 9q square plus 12q plus 3 plus 1. Let me split this 4 as 3 plus 1. So that I can take 3 common outside from the first 3 terms. So first term 9q square, when we take 3 outside it is 3q square. The second term is 12q, it reduces to 4q. And the third term will be plus 1. Plus the other one, the remaining 1. Now here again this is going to be an integer value and let me denote it by the symbol m. So I have expressed x square is of the form 3m plus 1. So whether x may be of the form 3q or 3q plus 1 or 3q plus 2, x square is of the form 3m or 3m plus 1. So this is what we have proved, that the square of any positive integer is of the form 3m or 3m plus 1. That's it.